matrices are this is matrix. It is this is matrix is this these are matrices. M number of rows are here, M number of columns are here. It is some arranged order arranged in some rows, in some columns, like this. So these are rows and these are columns. So number of rows is M here and number of columns is N here. Two suffixes are there for every entry. First one is row number and second one is column number. Then transpose is this: rows we are writing as columns we are writing as rows. Again, transpose of transpose, it is a same matrix, original matrix. A is of order M into N, and AT transpose is of order N into M, like this. So if it is A, it is 3 by 2. So here these rows are written as columns and columns are written as rows. So these are transpose. Then adjoint means for this we need a square matrix. Number of rows and number of columns are equal. So cofactor. For first we find determinant. Determinant is this, determinant of A. Then it is to be remembered. So determinant is, value is this summation Aij, capital Aij. This Aij are for cofactors. Cofactor means cofactor of an entry is what? This is if a square matrix, then cofactor is we omit number of rows, the ith rows and ij column, and then that n minus 1 order determinant will be the cofactor of Aij, this small aij. This is capital Aij. So this cofactor adjoint of a square matrix. So we remind this cofactor. So cofactor is, suppose we are considering say 3 by 3 matrix. 3 by 3 matrix. So 2, 3, 1, minus 1, 0, 2, 5, 6, 1. Then so A suppose we are considering A 2 1. So A 2 1 here is minus 1. This position A 2 1, second order, second row and first column. So A 2 1. So cofactor of A 2 1 we write it as this A 2 1, and this is equal to first we write minus 1 to the power. This is sum 2 plus 1. 2 plus 1, and then the determinant we write as determinant. So we omit second row and first column. So remains 3 1, 3 1 and 6 1. So value is 3 minus 6. It is minus 3. So this one is minus, this is minus, and it is 3. So this is cofactor of. So for this A21, this is the capital A21. So in this way we find cofactors, and cofactor adjoint A is then we determinant A is this, then determinant A is this one, summation Aij, and adjoint of a square matrix is defined as a transpose of the matrix Aij. So Aij, these are a cofactor we write. So in this case, for this example, so if it is A, then we write the matrix cofactor matrix we write as, for A11 cofactor is 0 into 1 minus 6 into 2, it is minus 12. For A12 it is minus 1 minus 10, it is minus 11 plus 11. And cofactor of A13 is, it is minus 6. Then cofactor of A21 is minus 3. Then cofactor of A22 it is 2 minus 5, it is minus 3. Cofactor of A23 is 12 minus 15. 12 minus 15, it will be minus 3, so it is plus 3. Then cofactor of a31, it is 6. Then cofactor of a32, it is 4 minus 4 plus 1. 4 plus 1 4 plus 1 is 5, and we take the negative of this 5. Then it is a33, it is 0 minus, this is plus 3. So this is adjoint, this is cofactor matrix. And adjoint A is, so adjoint of A is transpose of this B dash, and B dash is this is minus 12, 11, minus 6, then minus 3, minus 3, 3, then 6, minus 5, 3. So this is adjoint A. So this notation, it is Aij. So this B is the cofactor matrix. So Aij are cofactor. So B is the cofactor matrix. It is this. So adjoint of A is this one. So for these are examples. So A is the matrix. Then A11 is 5. A12 is minus 2. Minus of minus 2 is plus 2. A21 is this 1, and A21 this will be minus, it will be negative sign, and A22 is 3. So this is determinant is 17. Then adjoint A is this is 5, 2, and minus 1, 3. Then A into adjoint of A is this A into I, determinant A into I. So this is the way of finding adjoint of A. So this is another example. These are the cofactors. So cofactors are this. Then adjoint A is the cofactor, transpose of the cofactor matrix. Then determinant A we are getting as minus 6, and we are getting this as this one. So in this way we have A into adjoint of A, or adjoint of A into A as determinant A into I. And inverse we define like this. So A is a n square matrix. This is the definition of inverse. If AB is equal to BA is equal to I, then I is the identity matrix. Then we say B is the inverse of A. So A is a non-singular matrix. Non-singular matrix means determinant A is non-zero. Then we can have this one, B is equal to this. Then this is the A inverse. So A into A inverse, this is A inverse into A, it is I. So to find inverse of a matrix, first thing we have to find determinant of this. Then determinant of if it is 0, then we need not find this, because inverse doesn't exist then. Then if it is non-zero, then we find the adjoint A cofactor matrix, and then we have this 1 by determinant A into adjoint of A. So these are the examples of finding this determinants. So A here, adjoint A is this. We are finding all cofactors. So cofactor of 1 is 1, minus 1, minus 0, it is minus 1. Then cofactor of this one is this is plus 1 minus 0. So it is plus 1, then it will be minus 1. It will come here because we are taking the transpose here. Then cofactor of 4 is this minus 4. This is minus 4. Sorry, minus 2. Minus 1 into 2 minus 2. This is 0. So the cofactor of this will come here, minus 2. Then cofactor of minus 1, it will go here. Okay, this is 3 minus 8, and it is negative of this, so it is like this. So these are the way of finding this inverse of a matrix. Then transpose of A is very simple. We are writing rows as columns and columns as rows. These are the transpose. And adjoint A is this. So it is 4, this is 1, it is minus 1. Transpose of 1, it is minus 1, minus of minus 1 is plus 1. Then cofactor of minus 1, it is 1. We have to write minus 1 here, negative of this, because we need to multiply by minus 1 to the power I plus j. So this is 0, so like this. So these are the way of finding adjoint of A. Then inverse is this procedure. After finding adjoint of A, we divide by determinant. So these are the examples. So these are transpose of the following matrix. So then adjoint of, say, we are considering this one, say number 3. So adjoint of A, first we write Aij will be, then 0. For 0 it is 8. For A12 it is 4, so it will be minus 4. For A13 it is minus 1, minus 6, so it is minus 7. For A21 it is 4 minus 1, it is 5, so we take negative sign, so it is minus 5. For A22 it is 0 minus 3, it is minus 3. Then for A23 it is 0 minus 3, it is minus 3. We take the negative sign in this place, it is plus 3. Then for A31 it is 0 minus 2, it is minus 2. For A32 it is 0 minus 1, it is minus 1, minus of minus 1 is plus 1. And for A33 it is 0 minus 1, it is minus 1 again. So this is adjoint A, this is cofactor matrix. Then adjoint of A is transpose. So transpose is 8 minus 4 minus 7, then minus 5 minus 3 and minus 2 1 minus 1. So this is adjoint. The inverse, so we like this, we find it adjoint, and then we divide by determinant A. So number 3. So number 3 is it. In this way we find the inverse. Then solution of solution of simultaneous linear equation. So this is the system. So this is A, it is 3 by 3 matrix. This is 3 by 1 matrix. So A into X will be A1X. So if we see AX, what is AX? AX is equal to what we have, A1X plus A2Y plus A3Z. And second element is B1X plus B2Y plus B3Z. Third element is C1X plus C2Y plus C3Z. So this is the product AX. It is of order 3 by 1. And because AX is equal to B, so corresponding elements are equal. So this element is equal to D1, this element is equal to D2, and this element is equal to D3. So this gives us this equation. So system of linear equation, we can write like this: AX is equal to B, product of matrices. So X, then if we find A inverse, then A inverse multiply by this, then A inverse. So A inverse into AX, it is right hand side, it is A inverse into B. So A inverse A is I, So it is x, and it is A inverse into B. So we find A inverse, then multiply by B, and then we get the value for x. So these are some examples. Try 6 plus 4y equal to 5. So this is second order. So it is coefficient matrix is 3, 4, 2, minus 7. Then it is xy, it is 5, 1. Then inverse. First we find the inverse. So minus 21 minus 8, it is the determinant of A. It is minus 29. And then we find adjoint A. Adjoint A is this one, minus 7 minus 4 minus 2 minus 3. Then after division it is 7 by 29. This is A. So this is A inverse. So A inverse into x. So x is equal to x vector xy is equal to A inverse into 5, 1. Multiply this and we have this value 39 by 29, and this y is 13 by 29. Similarly this one, same procedure. Then this is also second order. Very simple. Here it is 1. 11 minus 10, it is 1. So determinant is 1. Then x equal to minus 4 equal to 1. Then this is third order. So third order, here you see thrice x. So coefficient matrix is 3 minus 1 2 1 2 1 5 3 2. This is A, this is x, and this is B. So A is this, and adjoint A. So cofactor, first we find the cofactor. Cofactor is cofactor matrix is this is say Aij, cofactor matrix. So cofactor matrix. So cofactor of 3, A11. A11 is 4 minus 3, it is 1. Cofactor of A12. A12 is 2 minus 5, it is minus 2 cofactor of this one, it is 2 minus 5, it is minus 3. Minus 3, this is minus 3, so this becomes plus 3. Then cofactor of 2 is A13 is 3 minus 10. 3 minus 10 is minus 7. Then cofactor of A21. A21 is minus 2 minus 6, it is minus 8, so it is plus 8. Cofactor of A22, it is 6 minus 10, minus 4. Cofactor of A23 is 9 plus 5, 14. It will be minus 14. Then cofactor of A31 is minus 1 minus 4, minus 5. This is minus 5. Then cofactor of A32 is 3 minus 2, it is 1, it will be minus 1. And cofactor of A33, it is 6 plus 1, it is 7, it is 7. So this is cofactor matrix, and adjoint is the transpose. So 1 3 minus 7, then 8 minus 4 minus 14, and minus 5 minus 1 7. Determinant A is minus 14. Then this is the A inverse. Then xyz we have like this. Similarly this is, so procedure is same. These are the values like this. Then this is another example. So solution is this: x equal to 2, y equal to 2, z equal to 2. Then so this is another example, worked out example. So this is a way to solve this type of equations. This one is another example. Here it is fourth order. We are taking fourth order. So it is x, y, z, w. This one. So fourth order we find adjoint is like this. Then A inverse is minus 23. Adjoint we have found like this. And then this product is this one. So we get these values. So x, y, z, w, we get it as 1 0 0 1. So these are the solutions. So x equal to 1, y equal to 0, z equal to 0, w equal to 1. This is again third order. So this is the way to find this. Then exercises are same procedure. So here what you can write, or coefficient matrix is number one, cofactor matrix is A is equal to 3 3 2, then 1 2 0 1 2 0, and this 0 10 3 0 10 3. So A is this. So we find Aij. It is, so cofactor of 3 is 6. Cofactor of 3 means A11. Cofactor of A12 is 3. It is minus 3. Cofactor of A13 is 10. Then cofactor of A21 is 9 minus 20. 9 minus 20 it is minus 11. Then cofactor of A22 is 9. This is 9. Cofactor of A23 is 30. It will be minus 30. Then cofactor of A31 is 0 minus 4. It is minus 4. Cofactor of A32 is 0 minus 2. It is minus 2. It will be plus 2. Then cofactor of A33 is 6 minus 3. It is 3. So this is cofactor matrix. Then adjoint of A is 6 minus 3 10, then minus 11 9 minus 30, and this is minus 4 2 3. So this is adjoint A. Then determinant A is 18 minus 9. It is plus 9. Plus 9 plus 20. It is 29. So determinant A is 29. And 18 minus 9. So it will be 29. Then what we have, 18 minus 9 plus 20. Then A inverse is is 1 by 29 into this one, adjoint A, 6 minus 11 minus 4, then minus 3 9 2 10 minus 33. Now we find A inverse of B. B is 142. So B is 142. So A inverse B will be, A inverse B is 142. So 1 by 29 we keep it here. Then it is 6 into 1, it is 6. Then minus 4, 6 into 1 plus minus 11 into 4 minus 44. So it is 6 minus 44 plus 8. So it is 14 minus 44 is minus 30. So 6 into 1, then minus 11 into 4, it is minus 44 plus 8. So 14 minus 44. So 14 minus 44, it will be 30, minus 30. Then 1 into minus 3, it is sorry, minus 3 into 1, it is minus 3. Minus 3 into 1, it is minus 3. Then 9 into 4, it is 36. And 2 into minus 2, it is minus 4. So it is minus 7 plus 36. Minus 7 plus 36, it will be minus, then next is 10 into 1, it is 10. Then minus 30 into 4, it is 120. And 3 into minus 2, it is minus 6. So we have this. Adjoint is 6 minus 11 minus 4, minus 11 minus 4, 6 minus 11 minus 4, 2, then 120 minus 20 minus 12, 20, this is, sorry, 10 minus 12, it is minus 2. It is x, it is 2. The answer should be this one because it satisfies this. So 2 into 3, it is 6. Then 3 into 1, it is 3. 9. 9 minus 8, it is 1. It should be this one. So it should be equal to, I think, 58. So somewhere it is wrong, I think. 40. Is it positive or what? So this is 6, then this one is 3, this is 3, this is 1. It is 9 minus, oh, this is not minus 11, it is plus 11. Cofactor of this one is, it is, cofactor of this is 9 minus 20, it is minus 11. But for this it will be plus, so it is plus. This is plus. So this is plus, so this is plus. So it is plus. So now what we have, this is 58. So this is equal to 1 by 29. This is 58. Then what is this one? This is, it should be equal to 1. So it is 7. 6 minus 7 is 29. So this is 29, and it is 4 minus 124. Minus 124. It will be 4. 6, 10. 10 minus 6 is, oh, sorry, it is 118. This is 4. 1 minus 120 plus 4, it is 116. This is 116. 116. So it is, so it is, answer is, this is 2. Then so our vector is 2, 1, minus 4. So x is 2, y is, so this is the way So for this calculation, this should be done carefully, otherwise this mistakes will come out. So this is the way. Then come to characteristic equation of a square matrix. So characteristic equation, it is A is a square matrix, then scalar value lambda, we find A minus lambda I. This is a matrix. Then we find a determinant. So this is the determinant of A minus lambda I, and we equate it to 0. We have some polynomial in lambda. So this is the characteristic equation of a matrix. So this is determinant is product this into this minus 6. So this is the characteristic equation of the matrix. And this lambda, when we have some equation, we get some solution also. So for this, lambda is equal to plus minus root over 7. So these are the characteristic roots. So this is the way. Then these are the some properties. The product of the eigenvalue of a matrix A is equal to determinant. So eigenvalue means these are the so 7 into 7 into, so root over 7 into minus root over 7, it is 7. So here is the determinant, it is minus 1 plus 6, minus 1 minus 6, it is minus 7. So this is root over 7 into this one is, it is minus 7. So this is the product of the eigenvalues or these are roots. This is equal to determinant A. If one of the eigenvalue is 0, then A is singular. Obviously it is. If it is 0, then product will be 0. Then if these are the eigenvalues of a matrix, then Ka, the K into this. So these are eigenvalue of Ka are, you multiply every element, every value with K. Then A to the power m. So it is A to the power means m means A into A into A. So we have some another matrix. So for this, these are the eigenvalues. Then A inverse is reciprocals. So these are the properties. And another property is every square matrix satisfies this characteristic equation, and this is called Cayley-Hamilton's theorem. So these are the examples. So these are square matrix, all square matrix. So characteristic equation is these are that. So how we find it? Actually, A is A minus first A is given. So number 1 we writing here. So A minus lambda I. First we write this matrix A minus lambda I is equal to A is 2 2 1, then 1 3 1, then 1 2 2. This is A. And lambda I is, I means 1 1 1. So I is a unit matrix. So lambda into 1, then lambda into 0, lambda into 0, then lambda into 0, then lambda into, only diagonal elements are 1, then 0 0, then lambda into 1, this lambda. So this is lambda I. Then we are subtracting. So 2 minus lambda, 2 minus 0, 1 minus 0. This is the first row. Then second is 1, then 3 minus lambda 1, then 1 to 2 minus lambda. Now we find a determinant, and we have some equation in lambda, and this is transformation of determinant to find the values. So these are properties of determinant. So R3, this is because it is 1 1. So to simplify the this procedure, we do it like this. So R3 R3 minus R2. So this is third row, this is second row. So 1 minus 1 0, then this is coming here 2 minus 3 plus lambda, this is this one, and this 1 minus lambda. Again we are doing this C1. So C1 plus C2 plus C3. So C2 plus C3 we are writing as C2. So this becomes 0 now. Now we are having this. So 2 minus lambda into this one, 4 minus lambda into 1 minus lambda. This after expansion we get this equation, and it is factorization of this. So lambda minus 1 whole square. We factorize these things so that we have the roots. So it is lambda minus 1 whole square into lambda minus 5. So roots are, so these are the roots. So two repeated roots, this 1 and 1, then this is 5. So these are the characteristic roots or eigenvalues. Then characteristic equation of this matrix. So this one. So these are 0. So it is very simple to simplify. So these are all 0. Only the diagonal element will come. So it is already factorized. So roots are 1, 3 and minus 2. Then third one is this one. So 1 minus lambda, 2 minus lambda, minus 1 minus lambda. This is the third one. 1 minus lambda, 2 minus 1 minus lambda. So after expansion we have it like this. This is again factorizable. Then characteristic equation. This is second order. It is very simple. Second order. Only quadratic will come out. Then this is again 2 minus lambda. For the fifth, number 5 is this. One. So minus 2 minus lambda, 1 minus lambda, 0 minus lambda. So 5 is here. This one. So this is something complicated. So you factorize this and simplify this. Then you find some common factor for this. So we are having 2 plus lambda common factor. So 2 plus lambda common factor. This is again second. No, not 2 plus lambda plus 3 it is coming out. So lambda plus 3 is the common factor. Then we have a quadratic equation, quadratic form. It is simple to simple to do. So the roots are minus 3 and 5. Then characteristic roots of A inverse. So to find characteristic roots means we find characteristic root of A and then we take the reciprocal. We need not find A inverse. So characteristic equation, this one. So it is 2 minus lambda, 3 minus lambda, 2 minus lambda. So from this we have characteristic roots as 3 minus 3, 1. This is characteristic roots corresponds to this matrix A. So for A inverse we take the reciprocal. So it is 1 by 3 minus 1 by 3, 1. Then characteristic equation of this is this. So we just find characteristic root of A and then take the reciprocal. This is the way to find this one. So this is another example. This is another example. So then this one is verify Cayley-Hamilton's theorem. So Cayley-Hamilton theorem is we for example 1, 2, 3 and 4. So 2, 3 and 4. What was that? 1, 2, 3 and 4. 1, 2, 3 and 4. This 2, 3 and 4. So this is second order matrix. This is third order. So let us see these things. Characteristic Cayley-Hamilton's theorem. So first we write this one. This characteristic equation, and then in place of lambda. So this is A square. So we in place of lambda we need to write A. These are all scalar. So this is after putting this A, this is matrix, this is matrix, this is matrix. So with 6 we have to multiply by I, 6i. So this is A cube. A cube is this. We are putting in place of lambda cube. Then A square we are putting in place of this one. So minus 2A square. So A cube minus 2A square minus 5A, and this is I. So we are simplifying this and we are getting all 0. So it is satisfied. 0 means it is the 0 matrix. Similarly this one, then this is characteristic equation, this one. So it is, so this is the way to verify Cayley-Hamilton's theorem. We find characteristic equation, then we write in A as a square. For lambda square we put a square, for lambda we put I a, and for which 6 we need to write I. So this is the way, so that this satisfies the matrix equation. Deduce the inverse of the matrix, and so this is also some way to find inverse. So this is the matrix equation. Then what we have, this is 0 we are having it, so from this what we get, this a square minus 4 is equal to 5i. So 5i. Then a inverse is what, we take this a, we multiply by a inverse, then this becomes a inverse into a square, it is a, then minus 4a inverse into a, it is I, and this is 5i into a inverse, it is a inverse. So 5 a inverse is equal to a minus 4i. So in this way also we can find inverse. Then verify the characteristic equation is this. Then we are writing this one, characteristic equation, it is the solution of this, and from this also we can find inverse. So this is a matrix equation, this is the matrix equation, this is equal to 0, so this is matrix equation is 0. So I is this, so a inverse is multiplied by a inverse, so 3 into a inverse is a square minus 6a plus 8 into I. So this is the way to find a inverse. And then characteristic equation is so procedure is same, only the calculations. So 8 minus lambda, 7 minus lambda, 3 minus lambda, then take the determinants, then factorize, we get this roots, these are the answers. So this is the all about the matrix. Then this linear programming problem. So linear programming problem is, it is this one, important component of modern mathematics. It is an important tool of tackling many problems of economics, management and commerce, and even in warfare. The following problems will illustrate this. So furniture problem. A furniture maker has 6 units of wood and 30 hours of free time, during which he plays to make decorative screens. So 2 models have been sold well in the past, so he wishes to restrict himself to those 2. Means what it is, this is the optimization problems. According to the estimates, model 1 requires 2 units of wood, 7 hours of time, while model 2 requires 1 unit of wood and 8 hours of time. So the prices of the models are rupees 120. So 2 models we are producing by, and for this we have to find the hours also. In how many, what should be the period of time, so that we can optimize the value, maximize the sales revenue. So these are the optimization problem. So and for this we need this linear programming problem or special type of optimization problem. So many things are there to optimize these things, but this is one tool. Linear programming is a tool for optimizing simple problems. Then here some objective functions will be there. There are some linear constraints. So linear constraints, so this involve linear, and programming refers to method of determining particular program in a plan of action. Then linear equation in 2 variables. So for this we need only these things, only 2 variables are there. then only we can do it. So for many, so when there are more than 2 variables, then we cannot do it using this method. So for this we know these things, we should know these things. So this is ax plus by, so 2 variables are there, so these are constraints. So ax plus by, it is less than some value or maybe greater than some value, so we write this as equations. These are straight lines. So ax plus by, so this is say ax plus by, so this is a so ax plus by, if we write this is equal to c, so this is a straight line equation. So we can plot for some this. Suppose this is a straight line, then so when you say less than c, so less than c means we'll have some values for this. This may be this side or this may be this side. So so this is the boundary, this is the boundary. So we are talking about this side or this side depending on the equation. So this straight line will so this is a plane, this is a plane, and this straight line is dividing this half planes. This is half of this is half of this. So these things we should know. Suppose, so first thing we have to know this half planes. So solve twice x plus thrice y less than equal to 6. So how will you do it? So first you find twice x plus thrice y equal to 6. We need to draw the line. So twice x plus thrice y equal to 6. So what are the intercept form? It is x by 3 plus y by 2 is equal to 1. So to plot it, what we are doing, so it is x intercept is 3, y intercept is 2. So this is the line, this is the straight line, this is the straight line. Now less than 6, so less than 6 means x equal to 0, y equal to 0, this value is less than 6, means what, this 0 0 is here. So every xy satisfying less than equal to 0, less than equal to 6 will be in this side, will be in this side. So this is the region, this is the region where it is satisfied, where it is satisfied. So when we say solution of this, it is the all these things. This is inequality. So all the values here lying on this plane, the xy, say suppose minus 3 minus 4, it will be a solution of this. Say it is 1 2 1 2, this is a solution of this, because 2 into 1 plus 3 into 2, it is 5. So it is lying on this side. So every point lying here is the solution of this inequality. Then twice x minus thrice y is equal to 1. So this is first we draw the straight line. It is x intercept is half, if it is 1, x intercept is, so this is twice x minus thrice y, so it is x by half plus y by minus 1 by 3 is equal to 1. So x is half here and minus 1 by 3, y is minus 1 by 3, it is somewhere here. So this is minus 1 by 3, this is half, so you join it, this is the line. Now less than 1, so 0 0 is a point. If this is 0, this is 0, it is 0. So 0 0 lies on this plane. So this side, every point here, so this is the solution of this, because 0 0 is here. So every point lying to the left, on which side it is 0 0 is lying, and that side is the solution. So the region containing 0 0 is the solution. So this is the region which contains the half plane which contains 0 0 or 0 0. If it is not 0 0, so we can write also minus 2, minus 2 also you can write, minus 2 1. So minus 2 1, it is here. So this is the region containing the minus 2 1. So this is the solution of this inequality. Then solve x greater than 1. So x greater than 1. So because it is 2 dimension, x greater than 1, we do not know. If we consider a real line, then x greater than 1, if it is 1, so all these points, but we are talking about the plane. So this is the straight line x equal to 1. So greater than 1 means all this region, all this value. So this is the region, this is the region, and this is the solution. So the point 30 satisfies the inequality 30. So the region containing 30 is the solution. So this is this is the line x equal to 1. It is dividing this to two sides, half plane. So this half is the solution. Then mod of x minus 2. So to solve it, x minus 2, it is modulus. So x minus 2 means x minus 2 greater than 1. So this is 1, this is 2. So x minus 2 is greater than 1. So this is 3. This is 1, 2, 3. Means what? This is 3. This is 3. It is 2. So x minus 2, if x is in between this, then it is not the solution. So it should be greater than 3 and it should be less than 1. So these are the value, these are the region, these are the region. So x is greater than 3 and x is less than 1. Then solve x minus 3, x minus 5y is less than minus 1. Same procedure, we draw the line x minus 5y, x minus 5y is equal to minus 1. We have x by intercept form, we write x by minus 1 plus y by 1 by 5. 1 by 5 is equal to 1. So x intercept is minus 1. Here it is minus 1. Y intercept is 1 by 5 somewhere here, say. So this is the line. This is the line, and it is dividing this to two parts. So 0 0 0 0 is where? If it is 0 0, then it is not satisfied. Means what? 0 0 doesn't belong to the solution. So 0 0 is here, 0 0 is here. So this is not the solution. This is not the solution. So to the opposite side. So this is the solution. So this is the solution. Suppose the point, say 1. Suppose you are considering the point 0 1. So if it is 0 1, then this is 0, this is 1, it will be minus 5. So minus 5 is less than minus 1. So 0 1 is a point, or minus 2 0. Minus 2 0 is, this is also a solution. So minus 2 0 lies to this side. So this is the region satisfying the inequality. So this is the way to find this. So these are the region containing 0 0. So x plus 3 greater than 1. So x plus 3 greater than 1 means our region will be like this. Region will be x plus 3. X plus 3, this is 3. This is 3. So x plus 3 greater than 1 means x plus 2 greater than 0. So x plus 2 x equal to minus 2. So this is minus 2. So x minus x plus 2. So x plus 2 is this line, x plus 2, this is x plus 2. So x plus 2 minus x equal to minus 2. This is the line then here x plus 3. So if it is x is here, then x plus, this is x, it is say 1 point, this is 1, then 1, and this is this value, the right of x plus 2. So this is the region where it is greater than 1. So this is the region 0, -1, -1 plus 3, it is greater than 1. So this is the region, this is the region. So in this way we find a solution of this. Then solution of simultaneous linear equation in two variables, it is the simultaneous linear. So suppose we are having two equations, then we'll have some point of intersection, and that is the solution for this. So suppose we have to find this, solve this one. So we draw the lines, then point of intersection we need to find. So solve this, converting equations with this. So we draw the, so this say twice x plus thrice y equal, so 4 lines we need to find. So twice x plus, so intercept of first line, it is 9 by 2. 9 by 2, suppose this is 4, this is 4, so 9 by 2 is here, 4 plus half, and then it is 3, y is 3, it is 3. So this is the line, this is the line, first line, twice x plus thrice y less than equal to 9. So this region. Then x plus 5y, so x intercept is 8, x intercept is 8 here, and y intercept is 8 by 5. 8 by 5 means 1 point something, so this is somewhere here. So this is the line here, this is the line, second line. So this is L2, this is L1. So less than, and then x positive, y positive. So in the first quadrant, so what do you see here? So both will be satisfied. So less than 0, 0, 0. So the region containing 0, 0 is the solution. So for this is the region, for this is the region. So this will be the solution. So A 3 1. So 3 1, this is the point A. This is A. Then B is 4.50. 4.50. This is B. This is B. Then C is, O is 0 0, point of intersection, and D is this one, 0 1.6. This is D. This is C. So A B C D is the region. So A B C D is the region. So this is the region which satisfies this inequality. Then this is also another thing, x plus y. So we draw the regions, x plus y less than 5. This is 5, say this is 5. So this is one line L1, this is the region here. Then x for second line, it is 4, x intercept is 4, x intercept is 1, y intercept is 4. Y intercept is 4. So this is the line, this is underline. Then getter part to this side. Then x plus 5y. So it it is 5, is 5, and y is 1. This is 5 and y is 1, somewhere here say. somewhere here. So this is the line, this is the line to this side. Then x less than 4, y less than 3. So 3, this is 3 is x is less than 4, it is somewhere here, and y is less than 3, y is less than 3 somewhere here. So we find the point of intersection. So this is 1 point, this is 1 point, this is 1 point, this is 1 point, this is 1 point. We get 5 points. So A, B, C, D, E, we find it. So this is the region A, B, C, D, E. So solution of this. So points of intersection are, we can solve it numerically. This to x plus y. So A is point of intersection of y equal to 3. So this is A, then this is B, this is C, this is D, this is E. So in this way we find the solution. Then this is to solve it. It is 3x plus y equal to 4. So the line is 3x plus y. So x intercept is 4 by 3. X intercept is 4 by 3. It is 1 point something. Y intercept is 4. Y intercept is 4. It is somewhere here. So this is a line. Then x is greater than 1. So this is x is greater than 1. This is x is greater than 1 to this side. 3x plus y greater than equal to 4 to this side, and y is greater than equal to 0. Means what? Our region is this one. This is the region. Not bounded, it is not bounded, this one. So this is the region outside this line and this line, and the y is also so it is also greater than y 0. Y is greater than 0 to above x axis. So this is the region. So this is the way to find the region. This type of regions we need to find to solve the linear equations. Then so this is system linear equation. Graphically we can do these things. Then these are LPP problems. LPP problems are this. Furniture problem, it is so our these are constraints. Furniture problems we have mentioned earlier. So these are the constraints. 2x plus y less than equal to 6. Then 7x plus 8y less than equal to 30. And our profit is this. This is the objective function. This is a function. We need to maximize this. So what we do, we find the region, we draw the region, and then this region if you see, then we mark the region. Then the corner points. So these are the corner points. When we have these values, these are the corner points. And maximization or minimization, this will be here. So this is corner point. We try this in the corner points, and where it is maximum we have the value. Then this is another illustration. So this is mathematical formulation. So these are constraints. X is in between 100 and 200, y is in between 80 and 170, and company is constant productivity. For this, x plus y should be greater than equal to 200. So this is the profit function. This is a profit function. We need to maximize it. So we find a region. and see the values. Then so this is the way to solve this type of problems. This is another problem. We refer to problem illustration of 5.3. So this is maximizing this. We draw the region. How will you draw it? Maximize this, then constraints are this. We draw the region. So 2x plus y. So if it is a straight line, will be like this. X intercept is 3 here. X intercept is 3. Y intercept is 6. So this is a line. Then second, it is x intercept is 30 by 7. It is 4 point something. 4 point something. It is 3. It is 4 point something. Then this is 30 by 8. 3 point something. 3 point something it is. So this is another line. Our region is this, less than. And so this is the region. So this is 1 point. So A is 0 0, B is 3 0, B is 3 0, C is 2 2. 2 2 is the solution of the 2, the point of intersection of this, and D is this point. So this is our region A B C D. So we try the values for these points. Z, this is the objective function. So this, for this value, these are the corner points. So our maximum value is 400. So this is the way to find the solve the problems, linear programming problems. So this is, we draw the lines, then find the regions, then find the corner points. Is A B C D. A B C D is, what are the points here? The lines we draw. This is 6. It is 12. First one, it is 12. This is 12. Then this is 9. This is 9. So this is one line. This is one line. Then Y 14,000 by 1,000. So this is 14. 14. This is somewhere here, and this is 7. Is somewhere here. Somewhere here. So this is one line. So our region is this. So A is 0 7. So this is 0 7. A is, this is A. Then B is A3. This is B. C is 12 0. This is C. And D is 0 0. So this is the region. So the corner points are this. We try this, and then we have the solution as 8 3. So this is the way to find the solve this type of equations. then this is another example. This is, so this is one example. So very simple things, these are very simple. You can check it, maximize this, and this is some model questions, and these questions we can these are practical problems for profit loss, and how we are projecting this to mathematical equations. So let's say these things. So we are forming these constraints. Then our objective function is this one, 50x plus 35y. So we need to maximize 50x plus 35y. Then so this is the way. So this is also another practical problem. So here our objective function is 10x plus 15y, and these are constraints. So we find a region from these constraints and find the points of intersection, and then find maximization is this one. In some cases we need to find minimization also. So these are all maximization. So these are the maximize. This is minimization. So we find the corner points, then find the minimum values. So in this way we can do these things.